All right, this is Saxon, Algebra 2. We're going to do a quick review of probability, finish the examples. Okay, so tell me what probability is. What is probability? Do y'all remember?
The chance that a specific event will occur.
Correct. The probability of one event happening is the positive outcome.
The total possible outcome.
Yes. Over the total possible outcomes. We talked about how do we fundamentally count the total possible outcomes. And there were two ways that we counted the total possible outcomes. One was, it's either a permutation or a combination. What's the difference?
For a permutation, order matters. For a commutation, it doesn't.
So order matters. Either the problem says order matters in order, or I want somebody first, second, third, like a batting order on a team. It matters. You don't just pick 9 people and say go bat, do you? No, somebody has to go first, somebody has to go second, right? Or if I am picking like the president, the vice president, the secretary, like it matters to me who's the secretary as opposed to who's the president. Order matters, right? You got it? Order doesn't matter if I just say I have these numbers 1, 2, 3 and just pick them. And I don't care there's only one combination, right? The only combination is 1, 2, and 3. When order doesn't matter. When order matters, then it's 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Those are permutations. All right? This is the fundamental counting principle of how we count the denominator. All right? Events. That's the events. Events can either be independent, or mutually exclusive. Independent events are like, I have 6 marbles and I'm going to draw 2 marbles. I'm going to draw a marble and I'm going to draw another marble. Those are independent events. Typically with independent events, you hear the word and you're multiplying the probabilities of each event. All right, we're gonna finish the examples. All right, mutually exclusive, it says I have 6 marbles. I'm gonna draw 1. What's the probability that I get a green marble or a yellow marble? That's what mutually exclusive typically looks like. And or means I'm adding, so it's the probability of a green plus the probability of a yellow. All right, so that's a quick review. Mutually exclusive is 2 different outcomes with 1 event. Independent is like 2 events, multiple events, draw. The event is actually what you do. Like you roll the dice, that's an event. You pick a card, that's an event. You pick a marble, that's an event. Independent events are typically 2 events with a particular outcome. Mutually exclusive is typically 1 event with 2 possibilities. Does that make sense? All right, so we need to pick up at 116.3 on page 471. All right, so it says, we did the multiple choice one. Never mind. We're picking up on number 4. How many 3-letter signs can be made from the letters in this word? If no repetition is permitted. So I want to make 3-letter signs. All right, they're all different letters. Like we don't have any duplicate letters. So how many letters do I have to choose from for this first one? 7. Am I multiplying or adding? Multiplying. Because I want this one and I want that one and I'm picking. They're independent events. It's 3 separate events of choosing numbers. Got it? Multiplication. How many numbers? How many letters do I have to choose from
6.
next? And then next.
5.
And what does this tell me? That's my denominator. Whatever that is. Now, if I ask you, what is the probability of picking those letters? It would be 1 over 7 times 6 times 5. The probability of one specific outcome, that being my positive outcome, over the total possible outcomes. Make sense? All right, look at example 5. Jamie has 5 places to put in her display. I just like to draw my 5 places. All right? All right, so I have 38 items to put here. How many different arrangements are possible? What do I do? How many items do I have to choose from for the first one?
38.
And then for the second one?
37.
And then for the third one?
36.
Times 35 times 34. Got it? What does this give me? This gives me the denominator. I'm not asking for the probability of a specific outcome. We're just looking at the fundamental counting principle. Does that make sense? The next part of the lesson is probability. All right, so look at example 6. We're rolling dice. So 2 dice are rolled. So I have 2 dice. Are they independent events? What happens on one does it have any impact on the other one? No. And both are going to be rolled.
Yeah.
Right? What are the total possible outcomes? How many numbers are on this dice?
6.
How many numbers are on the other dice?
6.
I multiply them because they're independent events. So that's my denominator, fundamentally. All right? A says, what is the probability of getting a sum of 7? Okay, this is how I always work these. And I guarantee you there's going to be a problem like this on your test. I don't think I've made it, but I'm sure I'm going to put a problem like this on your test. All right, so I look at my dice, right? I look at my dice. Can I get a 7 if I roll a 1 on this?
Yes.
That has to be a 6. Can I get 7 if I roll a 2 here? If it's a 5. Can I get a 7 if I roll a 3 on the first one?
Yes.
Yes, it'll be a 4. I almost wrote a 5. Can I, if I roll a 4 on the first one, can I get a sum of 7? What do I have to get on this one?
3.
What about if I roll a 5 here?
2.
2 and a 6 here.
1.
All right, so how many possibilities of that specific outcome? 1, 2, 3, 4, 5, 6. So it's 6 out of 36. Now, what about a sum? What about a sum greater than 8? Again, I look at the 2 dice. Can I get a sum greater than 8 if I roll a 1 on the first one? No. What about if I roll a 2? Greater
No.
than 8? No. Okay. What about if I roll a 3?
Yes.
Only the 6, right, is greater than 8. What if I roll a 4?
Yes.
Then I could get a 5 or a 6, right? What if I roll a 5?
Yes.
Then I can get a 4, a 5, or a 6. What if I roll a 6?
Yes.
Then I could get a 3, a 4, a 5, or a 6. So I know my denominator's 36 because it's 6 times 6. But how many specific positive outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see them? And then the last example we are going to go over is number 17. A fair coin is tossed 3 times. So I'm tossing it 3 times. Are those independent events? They are, so I am multiplying. All right? So I toss times toss times toss. Well, I should have, that looks like tails, right? Okay. What do we want? Heads. What is the probability I get heads every time? Heads, heads, heads. First toss, second toss, third toss.
1/2 times 1/2
Well, the probability that I get a head the first time is 1/2 times 1/2 times 1/2, which is 1/8. Okay, look how the last example differs from this one. Top of page 474. It says, a fair coin is tossed 4 times. It's kind of tricky. A fair coin is tossed 4 times, and it comes up heads each time. What is the probability it's going to come up heads the next time? It's just 1/2, because it's just one event, right? You see the difference?